Hello, lazy chemists, and today we're going to go over the process for naming covalent compounds. Okay, so last week we went over the process for how to name ionic compounds. Today we're going to go over the process for naming covalent compounds. And for the most part, today's lesson is going to be a fairly easy one. And most students are able to get covalent bonding relatively simply because it's just an easier concept than ionic bonding is in general. The only real issue that I have always seen is that a lot of students have troubles figuring out or determining whether something is a covalent compound or if it's an ionic compound. Or if they're just going to name it, they're just going to name it the covalent way because it's the easiest. So, for naming a covalent compound, the first thing that you need to do is make sure that it is a covalent compound. Okay, and the covalent compounds, those are all going to be from the nonmetals. Okay, so these are all the ones that are in here. If it's just two of these, carbon, nitrogen, oxygen, fluorine, some silicon, germanium, arsenic, all of these have to be the ones that are going to be your covalent compounds. Okay. So if it's made only of these ones right here, then you can go ahead and name it covalent. However, if it uses a metal, that's when it's ionic. Okay. If it uses only nonmetals, that's covalent. And that's usually the biggest issue that I have with this area right here. Other than the fact that people don't, practice it at all and then they wonder why they don't get it. Okay. These are also known as molecular compounds. So if you see a worksheet where this kind of question comes up and it's like, oh, well, figure out how to name this molecular compound. It's the same thing as a covalent compound. Okay. All right. Many compounds are going to have special names. And, these are, special names for compounds that we're going to see all the time. Okay. And we're just going to, lapse when we're going through these. So for instance, methane or CH4 is an example. Ammonia, which is NH4, and water. Though I should note that methane is actually the scientific name for CH4. It's just many people also know the name of it. Okay. And step one for naming these compounds is to name the first element. Okay. And the first element is going to basically stay the same. So if the first element is carbon, then the name of the compound is going to be carbon something. Okay. Step two is the second element. We're going to change the name of it to ide. So the second element is going to always end in IDE, no matter what. Okay. Step three is that we're going to use prefixes to indicate the number of atoms. All right, so one of the main reasons that we have to use prefixes is that molecular compounds have the option of combining in different ways. Okay, so you can have carbon and oxygen coming together, but they can come together in different ratios. And that's because of the covalent bonding that goes on. They're not going to come in direct ratios, but they can come in multiple types of ratios. So if you've heard carbon monoxide, that's one carbon and one oxygen coming together. Whereas carbon dioxide is going to be carbon and two oxygens coming together. All right? And so this type of, random coming together is why we have to specify in covalent compounds how many of each element there are. Okay. Now, these are the prefixes that you're going to need to memorize. Mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, deca for 10. Okay? Okay, step 4 is just one to really remember that if the first element only has one element, you're not going to use mono. So for instance, carbon dioxide, we don't say it's monocarbon dioxide because we just dropped the mono. If there's only one, we're going to drop it in the first one because we're lazy. Okay. All right. When the addition of a Greek prefix is placed in front of a vowel, okay, we'll go ahead and drop the A and for the actual vowel. So, for instance, instead of monoxide, we're going to drop the O from the mono and then go ahead and have monoxide. Okay. And then if it has an I, it's never going to be dropped. Okay. So let's go ahead and look at this one right here. Okay. All right. Now we're going to go ahead and take over. We're going to go to our big blue button and we're going to take a look at it. N to F6. N to F6. So, take N to F6. Alright? So here we have 2 nitrogens, which means that the name of this part right here is going to end up being dinitrogen. Okay? So, dinitrogen. Here we have 6 fluorines. So therefore we're going to go ahead and say hexafluorine. But we're not going to leave it as fluorine. We have to change the ending to IDE. Therefore this one is going to be dinitrogen hexafluoride. Okay? Let's go ahead and see if it gives us Come on. Too much. All right, this one is going to be our next one. So CO. Okay. Here we go. So we have just CO. All right. So this one, we have 1 carbon, which theoretically means that it would be monocarbon. However, on the first element, we're not ever going to write mono. Because if it's just that element, we're just going to leave it as. Whereas the second one, it's going to be monooxide. Alright, but because this looks weird, we're going to go ahead and get rid of one of the O's. And this is going to be carbon monoxide. Alright. So let's go ahead and do another one here. Let's go ahead and do SiO2. Okay. So here we go. We have another one right here. We have silicon and 2 oxygens. So this one is going to be silicon. Let's spell it right. Silicon. And then it's going to be dioxygen. Okay. But we don't want to leave it as dioxygen because it's a compound. And each compound is going to end with IDE. So we're going to subtract the ending and put IDE. And this is silicon dioxide. Alright. And this is really the most basic way for how we go ahead and name a whole bunch of these compounds right here. Alright. There's not really much to it other than, what we just went over here. Okay. And that's just a little video there. So let's go and close that down. Okay. And yeah, that's all that we really need to do for that. Okay. So from here, you guys should have some practice. Let's go ahead and throw one curveball in for you. Let's go ahead and do Na2O. And this one right here, well, this one, we would think, oh, okay, well, this one, we have to do disodium. And then we'd realize, wait just a second, sodium's a metal. Okay, so because sodium's a metal, we don't do any of this di stuff. Okay, so we would not have disodium. The reason is because this is a metal. Okay, this would not be disodium monoxide. The reason is that this is a metal. Okay, sodium is a metal. Metals we have to name ionically. Okay, so this doesn't work. Doesn't work. Okay, this one would just be sodium oxide. Okay, and the reason that we have to make sure that we're not doing anything like that is because we need to indicate that it's ionic, and we indicate that it's ionic based off of the charges. So we know that this is Na2O because of charges, so we don't need to worry about naming it with any kind of special naming pattern. Okay, so that's the big key that I want you to get out of this little point that we had right here, and that is that the naming is only for covalent compounds and not for ionic compounds. This special prefixes only works with covalent compounds. All right, so that's going to go ahead and close this out for today. And, as always, remember, be lazy.